Hello, it's Duncan. I promised at the end of the last episode that I would consider how optional properties would work out when applied to our dynamic map lenses, and for once I'm going to keep a promise, or at least start to. Before we get there though, we'll look at some developer ergonomics, how to avoid polluting the global namespace, and yet more cute applications of extension functions. I promised at the end of the last episode that I would follow up on these property set lenses that fell out of some of our refactoring. Just before I do though, I want to point out quite a nice advantage of just using maps, and that is that they're very easy to build. Looking at this update test here, we're using a place which is the first from places and places we're reading from a data file. That's not a very helpful test because we don't know where this international magic shop came from. But knowing that a place just wraps a property set, and a property set is just a type alias of map of string to any question mark, we can build ourselves a place very easily. How do we do that? Well, we can say a place is a place and build a map. Now if we were to run this, this map is empty, and so place won't have a display name because the display name is inside the map at display name and then text. So if we just run this test, then we fail with key display name is missing in the map. How do we put it in the map? Well, we just build a map with display name to something. What should that thing be? Well, let's just put in a string and find out. Run that. Now we get value for key display name is not a collections map. So we know we can put a map in here, something to something. What should that something be? Well, it should be a string at text. So this should be text, and we know that we want to make it International Magic Shop. Try that. Now we have a problem that our place extracts address components, so we can address that. See whether that works. And it does. And now we can lay this out. Something like that. Now it's true that we weren't given many clues as to the names of these things and the structure. But in return for that, if we were to try and do the same thing in our other test, this is the version where place is our generated data class. If we wanted to build a place inside here, then we'd have to say, okay, it's a place. Now, what's the first parameter to place? We need to put in a name and an ID and some types and a national phone number and an international phone number, and none of these things are defaulted. We could easily spend 20 minutes just filling in the first layer. And once we finish the first layer, we have things like address component that have bits inside them, all of which are non-nullable, so we'd have to provide values for. So static typing has its pros and cons. In return for knowing the structure of a place up front, in order to build one, we have to include all that structure. Whereas with dynamic typing, we can populate only the components that are actually used in our code. And in fact, in the case of the country code, which was the hard bit to populate, had we made this into a getter, like that, then everything would have been fine, but in fact we could have left this out as well, I think. There we go. So it would only be if we ever actually evaluated a place country code that things would blow up. This also illustrates that place has the option of validating its properties either when it's built or when they're required, and that flexibility can come in handy. So then let's just take that away, and that, we're back to running. Good. So now this is all nice and clean, but this code down here, well, it's a bit busy. I've moved this lens object function here over into our property set file. Let's just tighten that up a bit so you can see it all. But lens object always was a bit of a clumsy name, especially in a context like this where we're having to put in the types as well. We can partly address that by realizing that lens object of property set is going to be a very common case. We can use that whenever we have a nested property. So we could write ourselves a fun that is lens object, that takes a property name, and is just lens object property set given the property name. Don't know why we got that big import there. And now we could use that in here by just taking that away. That tightens things up a bit, but it doesn't compile because both of these functions have the same signature on the JVM. That's a problem we can solve with an @JVM name, and we just have to give it something plausible. I think lens object property set. Okay, good. Lens object is still a bit of a mouthful though. We'd probably prefer it if this was just lens, and now that's much nicer here. But the problem is that we don't know that these are lenses specific to our property sets. We don't want to pollute the global namespace. So what we'd rather like really would be that you had to import propertyset.lens. Unfortunately, propertyset is a type alias. It doesn't have a companion object. We can't add static properties to it, I don't think. But last refuge of a scoundrel, we can create another scope, and I think I'm going to make an object and call it property sets. Can't call it property set, but I can call it property sets. That would then be a place to put these two things, like that. And now users can import from property sets to get a nice short version. If you saw the episode on data classes, you may remember that the lenses here, we added as postfix functions, extensions, on the properties of the data class. Can we do the same thing here? Well, I think we can. We could define inline fun reified r, which is any, and now this is an extension on string, and we'll call it as lens, and that's going to call lens given the string. And I suspect we need to tell it that it's the lens of r. I could have refactored this version, but I want to leave them both in place, and that would allow us to go back here and say display name dot as lens. Now we don't yet have a non-property set version, so I'm just going to go over here, say get rid of that, and we will do another one of these to match that one, which doesn't have to care about what the type is because it is lens of property set. That allows us to get rid of that, and this one here we can say is dot as lens. Is that true? Platform clash again, so we can copy this, put it in there, and say as lens property set. And since we've renamed it, I think this is not lens object property set, but just lens property set. Run that. Good, and we're just being told that that shouldn't really be inline. Wonderful. Just notice that IntelliJ is saying that property sets is unused, which I can't help thinking is a bug, but never mind. Let's close this window so we're not offended by it. So now when we create our lenses here, I think that's probably as tight and expressive as we can make it. Let's look at where we use them again. Well, it's places like this. We do display name text lens get and display name text lens inject. Now the first time I derived these lenses, I made the lenses implement function types. So if we go to lens, here at the moment we've only got get, inject and update, but we could make lens itself implement the function which extracts from a t and r. Now a concrete lens object here isn't compiling because it doesn't, but we can fix that in here by adding in an invoke. So this would be override fun invoke. It would take this, which we're calling the subject, and return an r by calling get on the subject. Now things compile, that will let us go back to competition tests, and in places like this we could just use display name text as the function. Now we might want to do the same thing with inject here. We discovered that we couldn't do that by implementing two function types, but we could just have another operator function that had the same signature as the inject. So it takes the subject and the new value and returns a new subject, and that is inject subject value. Back here, then we can remove that and run. Now it passes, but personally this one in particular is a little cryptic to me, and this one we're eliding the get. Well, I'm used to it because of HTTP4K, but I'm not entirely sure it's all that expressive. The way that my brain works, I would like to say this dot get display name text lens. Well, that doesn't compile. Could we make it compile though? Well, IntelliJ is no help, but I think we could. We could write some function as an extension on any that was tool get and took a lens. We'll work out the type in a minute, but this would do lens invoke, or just call on this. Okay, so let's find those types. A lens has a subject and a sort of out value, and we can add these type parameters to our function. That's 1, that's 2, and now we're close. What's our issue? The issue is that a lens can only extract from a non-nullable thing, so I think we're going to have to say that t is at least an any. Still a problem. Required t found any, and that's because we want them to match, so that this needs to be t. Okay then, does this work? It does, excellent. And I think we might pull the same stunt here with the inject. So I don't like the function. This is inject, but we could say, better maybe, properties with display name text lens of the value. Again, that doesn't exist. Let's make it so. Function is going to be very much like this one, so we'll start from there. This is going to be t with lens of t and r. I'm going to call this of, which is an r, and this is going to be lens dot inject this value, which we called of. Does that work? Brilliant. A couple of little tidies. I think this would be clearer if this was our internal property set. And here we specified a lens, but I don't think it needs to be a lens. I think we can move up the type hierarchy. Because our lens is a function, I'm not sure there's any rig factor to do this for us, but looking back at lens where it is itself a t to r, we can replace that lens with the function, any function, t to r. In which case I think this we'll call extractor, as its job is to extract an r from a t. And this turns out to be a really nice function to make things like this read well. Now we can move these two out of here and into lenses, where we have our interface. We have a composition function defined as an extension. We've got a lens object. Let's put them in here, I think. And note that because these are just defined on lenses, we can go to our strong competition place where we're doing things. And for example, here where we've got display name text inject, we could say a place dot with display name text of new name if we import that. And again here we could say edit with lens dot get display name text if we import our get. One bracket. Oh, and wrong lens, that should be display name text. Run this one. And we've got 2 for the price of 1 with our extension functions. Right then, I think we'll commit that before we go on. So this is lens conveniences. Couple of issues maybe, let's have a look. Property sets is never used. Well, we know that's a lie, and function lens is never used. Well, we could make that used, I suppose, by making this string as lens make call that one. Run everything again just in case, and commit. Okay then, another thing I said I'd investigate is nullability, that is, I suppose, optional properties. So let's write ourselves a test and play with that. So this is nullable properties. And I think we'll work directly in terms of maps now. So we'll say val a property set is an empty map of string to any. So then let's create ourselves a lens. And this is going to be property name as lens. And I think we'll just try and extract a string for now. Let's just remind ourselves what happens if we try and extract that. So if we say a property set dot get a lens, and we'll run this test. And the answer is we get a failure, key property name is missing in the map. And that's this getter here that called it required, and so it comes out of here. I must say I'm slightly surprised that we're getting key property name is missing in the map. Can't remember what get value is supposed to do. Oh, it does throw no such element exception. Well, I suppose that's what we asked for. So let's document it with expect catching. we'll move this into the block, and we can say is failure and is a no such element exception. Reformat and run. Okay, so that's what happens if we say we need to extract a string, but there isn't one. And I think maybe I'll just pull that down into there for now. But what if we want to find something that might be there and we want to know whether it is or it isn't? So that would be something like a lens is property name as lens of string question mark. And if we were able to do that, then we would expect that applying that lens to a property set would be equal to null. But note that strict won't allow us to do that, as we can't build a lens of the right type. How do we build a lens of the right type? Well, I suppose first of all, why can't we build a lens? And the answer is because we've defined this as lens here. Not actually this one, it's this one we're trying to call as lens, but we said that R has to extend from any, which is to say not null. And that's because we're calling this required here, which again uses t_any, and the reason for that is because we're saying it's a required thing. It has to be there, so it can't return a nullable thing. So if we're to build a lens that can return a nullable thing, I think we have to work out what property set optional looks like. Let's go back here and write a test for that instead. So we'll comment that out. And now let's add ourselves another test. This is property set optional. We'll grab an empty property set. And now we'll pretend that our optional exists. So we'll say what happens if we said a property set dot optional of string question mark with a key of no such. And we'd like a function such that that returned optional, where optional is a string question mark. Okay, can we make this exist? Create an extension function, map a string to any dot optional. Yes. On map, yes. Okay, so that's a signature. It's not a bad one, but probably we wanted to say it is on property set. And that would mean that we don't need a K and a V. And this would return the T. Now, should it return a nullable T or a T? I think probably a T, because this T can already be nullable. I don't know for certain. What I think I'm going to do is take this, copy it out of here, and put it into property set alongside required, so we can see our implementation over here. Back to the left-hand side, and we're trying to make this work. So this is going to be optional of string question mark, like that, and we can import from there. Okay, if I try and run this test, it will obviously fail. And there it does. But in proper TDD mode, we can get it to pass by saying return null. I'm a little confused by that message, but it does highlight that this should be key, which is a string. I remain a little confused by the fact it won't compile here, but I suppose what it's saying is this T could be not nullable, and therefore null wouldn't be allowed. We'll just fix that like that for now, and check that our tests do pass, which they do good. But when I say pass, that's not very convincing. What we should really do here, I think, is say that expect that doing that is null. Good. But always returning null is no use to us, so what I think we'll do is we'll say in here that this is a map of key to value, and that if we were to ask for an optional string of where key is, that should not be null, it should be is equal to value. Now that will fail because of our hard-coded null, and that gives us something to fix. Now then, in order to implement this, we know that we are going to have to know the T that we really want, so we can copy this preamble. But we also know that we want to relax this restriction. So the actual signature should look like that. And now the actual implementation is a bit subtle. What we want to do is we want to say result is get the key, and that may be null. Now we've got our T, and we can ask the question if result is T, in which case we should return it. else, well, that's an error that we'll come back to in a moment. Does that work? Well, it does so far, that's good. Let's fill in a few tests. These are a happy path. What happens if we said optional int on no such? Well, I think that should be fine because it's not there, so we don't care what its type is. We can't fail to cast it. Check that's true. Yes. What happens if we ask for an optional int on the key that is there? Well, I expect that to blow up with that error, and there it is. Let's take the opportunity to improve our error message. So let's change this to expect catching. That is a block, that bit, and then here we can say it's a failure. It is a illegal state exception from our errors, and the message we want to be something, let's just work that out, format this a little bit. And I think something like value for key is not a something like int class. That obviously won't pass. Note that strict tells us what has worked though. It is a failure. It is an instance of illegal state exception. We've just got the wrong message. So let's fill in the message over here with value for key $key is, should have said not a, and then we'll put in here the reified t. So that's our t class. See what that actually comes out at. That's not bad. So we'll put that in there and run. Do pass. Good. Perhaps slightly odd that it doesn't know that it's nullable here, but I'm going to let that pass because over here I'm also interested in what happens if we call optional with a non-nullable thing. So in other words, if we take this one and move it down here, now what happens if we say optional string not question mark? Now in this case, strict is still allowing us to say is null. I think that's because we still have this question mark here, but we could remove that. Now having done that, this string question mark here propagates over to the type of the expectation in strict, so we can ask is null here, but we can't ask is null here, which feels like the right behavior to me. So I think this is going to throw, but let's just take that away and see what happens. And indeed we get the same error message by trying to extract a non-nullable string. Actually, I think that's pretty sane behavior. So we will say expect catching, and then these same expectations, except that it is going to be key no such is not a Kotlin string. And it's not a Kotlin string because it's null. Good. In fact, this behavior makes me wonder whether we need the difference between required and optional at all. Hello, it's Future Duncan here, with a teaser of what this actually ends up looking like after about another 20 minutes work. But it's Christmas time and you probably don't want to spend another 20 minutes away from your family. So I'm going to come back to this next episode. By the time you watch this, it's probably too late to get a physical copy of the book that I wrote in that price called Java to Kotlin Refactoring Guidebook. But I'll leave details of how to get an instant digital download in the show notes below. Thanks for watching and Merry Christmas.